Hi Math 1, this video is for task 3.6 and we're going to identify whether something is a function or not a function. So take a look at these things that we investigated during class. We have person 1, 2, 3, 4, okay, and over here there's party 1. Lots of people went to party 1, okay, and somebody went to party 2. That is a function. This is not a function, okay? This person, party 1, party 2, how in the world can one person go to 3 different parties? Okay, and so the idea here, to be a function, okay, what's a function? What's a function? Each person, okay, can go to only one party. And that's what it means to be a function. Okay, how about not a function? Not a function. Okay, what does not a function mean? Okay, this person, the person goes to several parties at the same time. You can't do that. Okay, can't do that. That is not a function. All right, and so we need to turn this into something a little more mathematical than people and parties. Okay, so over here, I want you to write. Okay, I want you to write inputs. Inputs, and then over here are outputs. Outputs. Now we're going to change our sentence down here a little bit. When it says each person, we have to change person to input. Each input, okay, can have only one output. Each input has an output. That's what it means to be a function. Okay, same thing over here. This is an input, okay, and then these are the outputs. You can't have one input have several different outputs. When you put one number in, one number is supposed to come out. Okay, so instead of person, okay, let's change this to an input. An input has more than one output. Okay, that's not a function. When your input has more than one output. Okay, so that's kind of what we looked at in class, just to kind of discover things. Let's write down some official math notes here. Okay, so a function versus not a function. If you are a function, so let's just highlight that word. Okay, if you are a function, if every input corresponds to exactly one output. Okay, and so you can think to yourself, if you want, a person, we're going to make sure we say the word input. Okay, a person can only go to one party. But when we say party, okay, that's the output. You can only have one output. Let's look at some of these things here to see if they are functions or not. Okay, so what if your information is in a table? Okay, so here's the inputs, and here's the outputs. I want to look very carefully to see, are any of these people repeated? Uh-oh, person 2, what are you doing, sneaky person? Can person 2 go to party 1 and to party 4? No. Okay, so this is not a function. This is not a function, okay, and the reason is 2 has 2 different outputs. It has 2 different outputs. Or you could say there is an input that has 2 different outputs. How about this table right here? Is this one a function? I'm looking at the inputs, and they're all different, okay, and they're all going to parties. So this is an example of a function. And the reason is each input has only one output. Okay, what would it look like if we had a graph? If we had a graph, okay? So I'm looking at, let's just talk about input 3. Put 3 in, okay? We get this y value. Oh, and we get another value. What's going on here? Can person 4 go to party 2 and party negative 2? Okay, this is not a function. Not a function. And so sometimes when you look at a graph, okay, you can kind of look at these vertical lines. I'm going to say not a function because there is an input. There is an input with several outputs, and that is not allowed. How about this graph right here? Is there any input that has more than one output? Okay, this one's good. This one is a function. This one is a function, okay? And so sometimes what you could do to determine this, okay, is a vertical line test. You can do a vertical line test. A vertical line test, you draw them, okay, can only touch once. Okay, can only touch once. If you touch once, you are a function. All right, let's go take a look. What if they give you the information in an ordered pair? Okay, so what you're going to do is look at the x values. 0, 1, look at all these people, 2, 3, they're all different inputs, different x's. Okay, so this is a function. This is a function, okay? Each input has only one output. Is this one a function? Let's look at the x values. 0, 1, 0 again. 0, 0, okay? First he goes to party 2, then he goes to party 4. That can't happen. This one is not a function. Not a function, okay? And the reason is 0 has several outputs. That is not allowed, okay? Sometimes they give you mapping diagrams, okay? And this is actually kind of nice. Person 0 is going to party 2. Person 5, how can you split your body and go to 2 different parties? That is not allowed. This one is not a function. Not a function, okay? And the reason is 5 has several outputs. Or you could say there is an input that has several outputs. Is this one a function? Yep, that's a function. Party, party, party. Okay, they could even all go to the same party if they wanted. Okay, this one is a function. Okay, because each input has one output. Okay, if a situation is a function, okay, if it is a function, so those are all the ones I did in orange, we say each input has exactly one output. Okay, and everything that I did in green up here, if you are not a function, we say there is an input that has more than one output. Input, output. Okay, let's take a look now at solving some equations. Okay, so sometimes it takes more than one step, okay, to get the variable isolated. Okay, isolated means to get it alone. Remember, when we're solving, we're going to get x equals. Okay, so here's what we're going to do. Okay, step 1. How did they make the equation? How did they make it? So we're going to find x. And then we're going to ask ourselves, what did they do? What did they do in making the equation? What did they do when they were making the equation? Okay. And then what are we going to do about it? Okay, we're going to undo the operations in reverse order using inverse operations. Okay, so let's walk you through this a little bit. Okay, so I'm looking at this equation. The first thing I'm going to do, okay, is build the wall. Okay, let's see. What did they do? What did they do when they were making this equation? Let's find x. Okay, find x. Here it is. The first thing they did, it looks like they multiplied by 5. Okay, so step 1, they multiplied by 5. And what did they do second? Step 2, it looks like they added 9. Okay, so how are we going to undo this equation? Okay, we're going to have to go backwards, and we're going to have to undo these things. The last thing that they did is the first thing that we're going to have to undo. The inverse of adding is subtracting 9. What's the inverse of multiply? We're going to have to divide by 5. Okay, so here's our steps. Okay, so this is how we're going to undo it. First thing is subtract 9. Okay, I'm going to subtract 9 from the left and from the right. 9 minus 9 cancels. So now we have 5x equals sign 15. Okay, it does look like it's getting smaller. It's looking good. Okay, so the second thing we have to do is divide by 5. That makes sense. I see multiply, so I'm going to do divide by 5 on the left and 5 on the right. 5 divides by 5, and all we have left is x. 15 divided by 5 is 3. Okay, so if the equation has more than one step, if it has 2 steps, we're going to have to undo 2 things. We have to undo them in the right order. Okay, let's get a little closer here. Number two. Let's see how they made this equation. Okay, so what did they do? Step 1, find the variable. Okay, here's the variable. What did they do to m? It looks like they divided by 3. And then what's the second thing they did? They took that and then they subtracted 7. So we're going to have to undo those things. Okay, so we're going to have to go backwards. Okay, so let's go in reverse order. The inverse of subtract, the first thing I'm going to do is add 7. And what's the inverse of divide? We're going to multiply by 3. Okay, there's our steps. Let's build the wall. Okay, step 1 is add 7. Add 7 to the left, add 7 to the right. Those should cancel out. We have m divided by 3 equals sign 6. Okay, the second thing I need to do is multiply by 3, which makes sense. I see divide, so I will do multiply. Please put a dot. Okay, multiply by 3. Or you could always do parentheses if you like. 3 divided by 3 cancels, and we get 18. Okay, let's keep going. How did they form equation 3? This one looks a little different because it's kind of rearranged. Okay, let's build the wall. Okay, step 1. Okay, what did they do when they made this equation? Let's find the variable. Okay, oh, 3p. It looks like they multiplied by 3. The second thing they did, okay, was subtract a 9. So I'm going to have to do some inverse operations here to undo these things. In reverse order, number 1, I'm going to add a 9. Step 2, I'm going to divide by 3. All right, step 1, add 9. Okay, add 9 to the right and add 9 to the left. Okay, so that gets rid of one of the things by my variable. Now we just have 3p. Negative 24 plus 9 makes negative 15. Next step is divide by 3. Divide the right side by 3 and the left side by 3. So p is equal to negative 5. Okay? It's okay to have the variable on the right or the left. It's the same thing. This is the same as p equals negative 5. And the last one. That's the last one. Okay, let's build the wall. What did they do when they were making this equation? Okay, let's find our variable. Okay, and this is by the closest thing to x is plus 4. So they added 4 first. The second thing that they did then, okay, what did they do to that blue box? They divided by 2. So we're going to do the opposite of this. Let's go backwards. Okay. The inverse of divide, the first thing we're going to do is multiply by 2. Instead of adding, we're going to subtract 4. All right, let's go do it. Step 1, multiply by 2. I'm going to multiply the left side by 2 and the right side by 2. So the 2 cancels with the 2. Okay, 1x plus 4 is equal to 14. The last thing we're going to do is subtract 4. Subtract 4 from both sides. 1x is equal to 10. Okay. When it says 1x, okay, that's okay. That is 1x, and here's another way you can write down 1x. That's 1x, and that's just 1x all by itself, okay? So this is the same. This is the same. You can write it either way, okay? And what we can do also, okay, is check. Let's show people how to check our answer. Is 10 the right answer? Okay, is that the right answer for x? So does 10 plus 4 divided by 2, does that make 7? Yes, it does. Great job, Math 1.